I am Rangarao Karnam and I have more than a decade's experience in developing and architecting Java web applications. I've been using Maven for almost a decade now, and in this course we will use real-world examples to understand the power of Maven. Maven does so many things that it's very difficult to define it in a single line. In this course we'll understand how Maven makes the life of an application developer very easy. We will automate different things with Maven like compilation, running unit tests, creating EARs and VARs, and also deploying applications in Tomcat. We will learn how to use Maven in combination with an IDE like Eclipse. We will learn how to use Maven archetypes to generate sample projects of different frameworks like Spring MVC, Struts, and Hibernate. We will also look at the various plugins that Maven provides. Welcome to this course. Let's now get an overview of what we would be doing during this course. We would start with getting a strong foundation on Maven. We would also discuss how a Maven helps a everyday developer, everyday application developer. Then we would move on to the fundamentals of Maven. We would discuss about things like build lifecycle, project object model, and dependency management, which is the key feature of Maven. We would also look at superpalms. We'll discuss project object model, which is the pom.xml, which you would have heard about in detail. We would look at the different steps in a build lifecycle in detail. And then we would move on to multi-module Maven projects. We will also discuss the best practices in creating a multi-module Maven project. Then we would create a web application using Maven, and we will also run the web application in Tomcat. In the last few steps, we would look at the important Maven commands, and also we would use Maven archetype to generate a few projects. What's stopping us? Let's start with our first example. Before we get our hands dirty and start with doing a lot of hands-on examples, let's get a little bit of theoretical background. We'll try and answer the first basic question, which is, what is Maven? If I go to the Maven website, maven.apache.org, it says Apache Maven is a software project management and comprehension tool. It's a very generic definition. I understand the problem that the creators of Maven have in defining what Maven does. Instead of trying to define what Maven does, let's look at what an everyday developer does. I'm a programmer in a project. What would I be doing? I would start with coding something. I would be developing something, writing unit tests for it, and probably packaging it. I would need to build a var or EAR or something. I would need to deploy this packaged var or EAR in a application server or a web server like Tomcat, Jetty, WebSphere. I would need to deploy this EAR probably to a test environment, a staging environment. A typical project has a number of dependencies. Let's take a simple web project which is using Spring MVC and probably Hibernate in the data layer. So the basic dependencies it has is Spring MVC, Hibernate, and probably JPA. A developer needs to take care of the versioning of these dependencies. Which version of Spring to use? Should I use 2.0? Should I use 3.0? Should I use 4.0? Which version of Hibernate to use? The great thing about Maven is it helps with all these things which are listed on this slide. It helps us to compile Java code. It helps us to build a jar. It helps us to run an application, a web application in Tomcat. It also helps us to deploy something to a test environment along with running unit tests. These are all the things that Maven can help us do. In addition to these, Maven also can generate sample projects for different frameworks using Maven archetypes. There are a varied range of Maven plugins which are helpful to do different kind of things, running automation tests, for example. Before we discuss more theory about Maven, let's get started with the first hands-on. In this course, we are going to use an IDE called Eclipse. Eclipse is a very good Java IDE. It's open source and it's free. If you would like to install Eclipse, you can go to our GitHub repository, github.com/in28minutes/ Maven in 28 minutes. That's where all the code that we would be using during this course is present. And you can go in there, and if you look at the first thing in the README, it has a link to installing Eclipse and Java. So you can use this guide. It's a complete PDF guide which would help you to set up Eclipse and Java. We would be using the Maven, which comes embedded in Eclipse in the first few examples. If you are looking at Maven for the first time, I would really recommend you to focus on watching the first 30 minutes of this course and then trying to install everything that you would need. Once you launch up Eclipse, you'd see a screen like this. I would close this up, and I would want to now create our first Maven project. How do you create a first Maven project in Eclipse? That's what we would look at right now. So the way you would create the first Maven project is doing a right click, new, and you can say project and say Maven. So I would say right click, new Maven project, and click next. For now, I would say create a simple project. There are things like Maven archetypes which would help us in creating a lot of sample projects, but for now, let's not go there. Let's say we'll create a simple project, and I'm saying use the default workspace locations. That means all the code would be stored as part of the workspace which I'm using right now. And I click next. The first thing that I would need to give in a Maven project is the name for this particular project. So what is the name of the project and why is it needed? Let's say I want to use Spring Framework in this particular project. It has a particular group ID, something like org.springframework. And there's an artifact ID. For example, the Spring jar, the core jar, the artifact ID would be something like Spring-core. The JDBC, Spring JDBC would have an artifact ID, Spring-JDBC. So basically, the name of the project, name of a Maven project, is the name which is used by other projects to refer to this particular project. So if some other project wants to make use of this project, how do they refer to this? That's basically the name. So the first thing is the group ID. For this particular project, I would say com.in28minutes is the group ID. You can think of group ID like a package name. So just like you use packages to group things, you can think the group ID are used to group artifacts. The artifact ID I would use is first Maven project. That's basically what we are doing in here. We'll talk a lot about version and packaging a little later. Don't worry about what else is there in here right now. We'll talk about all of them slowly. Click finish. There you go. Your first Maven project is ready and it's ready to be run. Before we run the example, let's see the folder structure which it creates. So once I created the Maven project, there are a few things which came in. One is you can look at 4 different folders which are created in here. Source main Java, source main resources, source test Java, source test resources. These are the default folders when in any Maven project. So source main Java typically holds all the source code. Source test Java typically holds all the test code. And if you need any resources, XML files, property files that you would need to run the source, then you would put them in source main resources. If you need any resources like XML properties to run the test files, you'd put them in source test resources. So this is a very simple Java project with source code in source main, test code in source test. The other important file which is created is the pom.xml. So the pom.xml is the most important part of a Maven project. The pom.xml defines a lot of things that are related to this particular project. Earlier, we gave a group ID on the IDE, and that's what is used in here. So the group ID is com.in28minutes. Artifact ID is the name that we are giving to this particular project, and there's a version. We would discuss about version in detail a little later. So this is your first Maven project with all the default folders and the pom.xml properly created. In the next step, let's look at creating a new Java file and a test file and see all the things that Maven can do for us. Welcome back. In this step, let's look at creating a very simple Java class and also write a very simple test for it. The way we would create a Java class is very simple, right? So right click, new class. I would use com.in28minutes. Oops. See. Okay, I should put it in the package com.in28minutes. Most important thing is I'm creating a source file, so I would create it in source main Java. So that's why I chose in here source main Java. So I did a right click on source main Java and said new class, and I would give the package name as com.in28minutes, and I would give the name of the class as app.java. Something, I don't really care what it is actually. I just want to create a sample file, so I'll just call it app and click finish. This would create a Java file for me. I'm opening up the app. There's nothing in here right now, so I just go in and say, let's think actually that this is something which does some lot of complicated calculations and returns this value back. We have an app with a small method return something which is just saying dummy. So we have the source code ready. So let's go ahead and create our test file as well. Right click, new, say other, and type in JUnit. So you can create a new JUnit test case, and I would use the same package as the earlier one, com.in28minutes. That's where we have the source file, and the name I would give it as app test. I'm going to test the app class, so I'm calling it app test. For now, I would say not now and click OK. This would give us a few compilation errors very soon because the JUnit framework is not in here. So now I would want this test file to compile. One of the ways is download the JUnit jar and add it to the build path. So if you know how to use Eclipse, you can download it. Probably you can copy the junit.jar to one of the folders and then go to right click and go to build properties and add in the junit.jar. But in that way of doing it, you're taking the complete responsibility of downloading the jar and adding it to the build path. And let's say one of your friends wants to run this project as well. What he needs to do is he needs to download the junit.jar and make it available in the build path. We don't want to do that. Is there an automated way of getting the junit jar into the build path? That's where we would use the pom.xml. In pom.xml, I can specify something called a dependency. So how do I specify a dependency? I can say dependencies, type in dependency. I want a particular dependency to be added in. So dependency, and when I specify a dependency, I have to give three different things about that particular dependency. First is the group ID. The second one is the artifact ID. The third one, can you guess? It's the version. Which version? So I would want in this particular thing to use the JUnit framework. I know that the group ID of JUnit framework is org.junit. If you don't know the group ID of JUnit framework, for example, what you can do is you can go to Google. Just go to Google and search JUnit Maven dependency, and there you go. One of the things is it comes up, the Maven dependency comes up, and here is the group ID, artifact ID, and the version. In this particular thing, the version which is there is 4.4. Copy this, and now I've copied this dependency, group ID, artifact ID, and version in here. The group ID of JUnit I found is not org.junit, but now it's JUnit. So JUnit, and the artifact ID is JUnit. The version which we are going to use is 4.4. There is a small thing called scope which should ideally be test, but let's not worry about the scope right now. So now we have added a JUnit in here, so into the thing, and you would automatically notice that the compilation errors disappeared. Let's play around with this a little bit. So if I let's delete the dependency from here. Let's delete the JUnit dependency from here. What would happen? Try this. You'd see that in a few moments it says the import is not found. And as soon as I add the dependency in and save, you'd see that all the compilation errors disappear. That's the magic of Maven. Actually, what is happening in the background when I add in the JUnit dependency is Maven is going to something called a Maven repository. So there is a repository on the net where all the jar files are present. So any jar file you'd specify by a group ID and JUnit and an artifact ID, that artifact is present in a global repository. And what we are doing, what Maven is doing is going to that repository and getting that version of the file. So it's getting JUnit 4.4, and what it's doing is it's also adding in that to our Maven dependencies. So in the dependencies of this particular project, a specific thing called JUnit 4.4 is added in, and now I can use the JUnit jar. I mean, I can use things from the JUnit jar like org JUnit test, org JUnit test asserts, all these kind of things from that particular jar. I can make use of them in this particular piece of code. So what we did during this step is we created a sample source file. So we started off creating a sample source file app.java, and then we wrote an app-test.java. The app-test.java for now, if you look at it, it's saying fail, but I would just remove the fail line. So I'll just remove the fail line. It's not really testing the app. That doesn't really matter. What we want to learn here is not how to write a unit test, but how to use Maven. So the fact that there is nothing in this test does not really matter as long as we are trying to learn Maven. So we have a source file, we have a test file, and in the pom.xml we added in JUnit jar because in the test class we wanted to make use of the JUnit framework. What we notice is as soon as I add a dependency in, the dependency is added into the Maven dependencies as well. Let's play around with it a little bit again. So I removed this dependency. You can see it has disappeared from the Maven dependencies as well. Now I would add this dependency in. Maven is downloading that particular dependency and it's making it available in the Maven dependencies. That's the magic of Maven. Maven takes care of all the dependency management for a project. So if I need any specific jars of any particular thing, let's say Spring, struts, I can add the dependency in here and Maven would take care of downloading it and making it available in here. What is the advantage because of that? The advantage is that now I can give this Maven project to anybody. I can give it to my friend and he would be able to use Maven to download everything that he would need, and he would be able to directly run the project without needing to worry about how to set this up. In the next step, we would discuss a lot more about the build life cycle. In the previous step, we created a source file, a test file, and we added a dependency to the pom.xml of the JUnit jar. So that's what we did in the previous step. Now, in this step, we would actually want to go further and use Maven to build the jar file. I would want to build a first Maven project.jar. So what I would want to do is I would want to do a first Maven project.jar. Actually, there's a friend of mine who wants to use this project. He wants the jar file so that he can put it in his project and he would be able to use the code from here. There's not a lot of code in here actually right now, but let's assume that I'm going to build a lot of algorithms in here which he wants to make use of. So what I would want to do is build up a first Maven project.jar. The thing about building up a first Maven project.jar is that it's not a simple thing to just build up a jar, because first thing I have to do is I have to compile the app.java. So first thing is I have to compile the app.java and create an app.class. As you'd know, any Java class would be compiled to a .class file. So I would need to compile app.java to app.class. If I had other files in here, and those files also have to be compiled. The second step is I would need to compile the test classes as well. So whatever is in the test folder, I would need to compile them as well. So apptest.java when compiled would result in apptest.class. So that's the second step. Compile all the test classes. That's the second step. The first step is to compile the source classes. The third step is run the tests. So I have to run the tests and see if they are all succeeding. If the unit tests don't succeed, then I should not build the jar, because the unit tests are failing. If the unit tests are failing, then it means that there is something wrong with my source code. I would never want to deliver something which is having a failing unit test. So I need to make sure that the tests are running fine, and then I would need to create the jar. So creating a jar, it also is not a simple thing. Actually, there are commands which are available in Java which can help you to create a jar file. So basically, I would need to package all the source files. Let's say if there are 5 source files, I have to package all of them into a specific format and create this Java jar file. So these are the different steps which are involved in doing a very simple thing like creating a jar. Earlier, what we used to do is we used to write and scripts. Ant was the Java build tool which was used before Maven, and Ant was used to write these kind of scripts. I've seen Ant scripts which run into thousands and thousand lines of code, and they are very tedious to maintain because they are large and you need to code everything that you need to do. So just doing this kind of thing would take you about 100 lines of code in Ant. And that's where Maven came in, and it made the life of a Java developer very easy. Let's see how we can build a jar file using Maven. When I run any Maven command, all the results of the compilation, the building process, everything would be stored in a folder called target. So if you open the target folder up, you might see a few things in here. The first thing I would want to do is to delete everything from the target folder. So I would want to execute a command mvn clean. So I would say maven build, and I would give a goal as clean. So the thing which I want to do is to clean everything in the target folder. First, I don't want anything in the target folder, so I would run this. So this would delete the target folder. So if you look at the whole thing after you execute the mvn clean command, you would see that there is nothing in the target folder. That's good. So now there is nothing in the target folder. Now I would want to do the first step. The first step which we discussed earlier in creating the jar is to compile the Java classes, right? So first thing I want to do is compile Java classes. So the source files. So I want to compile app.java and create app.class. Let's see how to do that in Maven. I have arranged my screen so that on the left side you would see Eclipse. On the right side you would see the folder where this particular project is in. So if you do a right click and do a properties, and this would give you, if you go to resource, this would give you where your project is in your local machine. So what I've done is I've opened up that particular folder in the Mac Finder, but you can go ahead and use Windows Explorer and open that folder up. This is what you would see. So right now you see a folder source and target. What we have done earlier is we did a mvn clean. What does mvn clean do? Right click, run as, I'll do mvn build, and the command I would want to use is clean. So run. What happens? If you look at what it would do right now, it's running and it's completed doing it. And if you observe on the right hand side, the target folder is deleted. So the mvn clean actually deletes the complete target folder. So it cleans up everything that Maven generates. Now let's run our first Maven real command, which is mvn compile. So I'm going to do run as Maven build, and I would say compile. So I'm saying compile and click run. The compile command actually compiles the Java file, the source file, and creates the class files for it. So if you look at the log in here, it would say compiling one source file to a specific folder. If I open that particular thing in here, that's target, classes, and then I would need to go into com in 28 minutes app.class. That is what is created right now. This app.class which is created in here is the class which is created from the compilation of app.java. So the way you compile source files in in Maven is by just typing in something mvn compile. Let's do the next step. Let's try and compile the source files as well. We would want to now compile the source files as well. How do I do that? The way you do that in Maven is right click, run as Maven build, and the goal I would need to give to Maven is test hyphen compile. I want to compile the test classes. Test hyphen compile. Let's see what would happen. Once you did test hyphen compile, it's running. You can see that in the console, it's compiling, and you'd see that there's a new folder which is created, which is test classes. If you go further and look at it, it would have com in 28 minutes app test.class. So when I said mvn test compile, so test hyphen compile is the goal, and then I would be able to generate the test files as well. I mean, I would be able to compile the test files as well. One important thing that you can observe probably while we did the mvn test compile, if you go to the console, is when I did an mvn test compile, the compile goal is also executed. So when I did a test compile, first thing it did was to compile the source files, and then Maven did the test compile. We have now compiled the Java source files. We have compiled the test files. So what do we want to do? We want to run the tests. We want to see whether the tests are succeeding or not. The way you can do that is doing a right click, run as mvn build run. You'd see the following things happen in the console. First thing is, it does a compile. There are things like resources, test resources. We will look at it later. Compile, test compile, and then it is doing the test. So what it's doing is it's running the tests. So it's saying tests run are 1 and there are 0 errors. So at the end it's saying all the tests have succeeded, and thereby the results of this particular build is a success. Let's just say there was a fail in here. Let's say I'm failing the test. So let's go to app.test.java and let's make the test to fail. So I'm just saying fail. So I'm causing the test to fail. Earlier when the test succeeded, it said build success. So the entire thing succeeded. Now I'm causing the test to fail. What would happen? Right click, run as. Now I'll use the mvn test which is there directly below. You could have also done maven build and typed in test. So I'm doing a right click maven test, and you would see that it's doing a compile. It did the test compile, but there's a failure in the test. So what it's showing in here is there's a failed test. So this test has failed, and therefore the build is failed. So that's a maven build failure. A maven build failure is when there is a compilation error or there is a test failure. All these things are called maven build failures. Now I'll remove the fail in here to make it succeed. Now what I want to do is, we have done the first 3 steps. We compiled the source files, we compiled the test files, we ran the tests, and the last thing we want to do is to build the jar. So we want to create the real jar. We want to create first maven project.jar so that I can give it to my friend. So how do I do that? That's by right click, run as mvn install. You can do mvn build and type in install. Install is the goal which actually creates the jar and also installs it to the local repository. We'll look at it a little later. So I'm typing in mvn clean install, mvn install. You see that the tests are running, and then it's doing an install. So you'd see here that it's building a jar file. So if you look at the console, you can see the tests are run. After that, the jar plugin would create the jar. So it's building up a jar, first maven project 0.0.1 snapshot.jar, and then it's installing it to my local repository. So this is what would happen in the install goal. If I go and look at the folder, you'd see that in the target folder, there's a jar which is created. First maven project 0.0.1 snapshot.jar. If you look at this particular jar, it would contain the classes that we wrote in the source code. So in this particular step, we looked at how when I run a simple command called mvn install, Maven does a lot of magic. So as soon as I run mvn install, the first thing Maven does is creates the classes. So that's basically the source classes. So these are the source classes com in 28 minutes app.class. The next thing it does is it compiles the test classes and creates com in 28 minutes app test.class. The third thing which it did is it ran the tests, and it also, if you look at the thing, it says 0 failures. So it ran the tests, and all the test results are stored into a folder called surefire reports. And then it built up the jar, the first Maven project 0.0.1 snapshot.jar, which if my code was perfect, I could share it with my friend so that my friend can use this particular project. So this is the beauty of Maven. So now that we had a little bit of hands-on experience around the mvn install command, we will look at the build lifecycle of Maven in the next step. In the previous step, we saw that when I do a mvn install, Maven does a lot of things. So when I run mvn install, first thing is it's doing a compile, test, and then it's building the jar up and installing it to the local repository. How does Maven know to do these steps? What are the sequence of steps that Maven does? That's actually defined by something called a build life cycle. Maven follows something called a build life cycle. Let's look at it in detail. The build life cycle defines the steps that Maven follows when you execute a command. The different steps in the build life cycle is what you see in the screen right now. For example, if I do a mvn test, so mvn space test, if you run it from the command line, then there are three things that get executed. The first thing is the validate. Maven checks if the pom.xml is valid. I mean, to check the XML syntax, check it against XSD and things like that. The next thing it does is it compiles the test classes. As part of compile, it also compiles the test classes as well. And then the mvn test would run the unit tests. So these three steps are run when I do mvn test. This is a command which we did not run, which was mvn package. So if we did mvn package, Maven would have created the jar file, but it would not have installed it to a local repository. If I do a mvn install, what Maven does is all the steps that are defined before it. So it does a compile, test, package. If there are integration tests, then it would run them too. And then it would also do the install to the local repository. So these are the sequence of steps which Maven always follows. So this is what is called a build life cycle. A build life cycle is nothing but the sequence of steps that Maven follows when you execute any command. So if you execute any command in here, the steps which are earlier to it are all executed. The build life cycle is one of the important things which makes Maven very easy to use. It kinds of creates a structure which all the projects can follow. So in any project, you'd first compile the source files, then compile the test, and then run the test. This is kind of the standard way you do things. Why do we need to do it? Why do we need to define these steps individually in an AND script file? That's what Maven eliminates by having this build life cycle. Now that we understood the build life cycle, let's look at the pom.xml in more detail. The expansion of POM is project object model. The project object model is where you define various things about this particular project. So there's an XSD that you need to adhere to. This is not really important. But if you look at the most important parts of the pom.xml, the first important part of the project is the name you give to it. The name you give to a project is a combination of a group ID and the artifact ID. So a group ID and the artifact ID is what is used to uniquely identify this particular project. So if some other project wants to use this, they can say, I want this group ID, this artifact ID, along with which version. So a version indicates which version of the artifact that you would want to use. For example, Spring has a number of versions, right? It has version 1.0, version 2.0. Now the latest one is something like 4.2.4. So this version is which version of that particular framework. So in here, the version indicates the version of this particular project. So we are right now working on 0.0.1 snapshot. A snapshot is to indicate the fact that this is a version in development. Once I complete the development for this, I'll make this version 0.0.1 so that others can use it. So when I see a snapshot in a version, then it means somebody is actively developing that particular project. I should not use it because a snapshot is something I'm developing right now. Once I complete development of this, what I would do is I'll make the version 0.0.1 and I will release a jar out. And anybody who wants to use that can use the released version 0.0.1. That's the name and the version inside the POM. The other things you define in the POM are the most important part of any Java project. Those are the dependencies. So this first Maven project is dependent on JUnit. It needs a version 4.4 of JUnit, and that's what is specified as part of the dependencies. Whatever you want as available to be able to run this project, whatever jars you need, all those things you need to specify as a dependency. Let's say I want the Hibernate dependency to run this project. How do I download it? Think about it. The way I can do that is, again, I would go to Google and type in Hibernate Maven POM, or you can type in Hibernate Maven dependency as well. It doesn't really matter. And then you would get the Hibernate Maven POM artifact details. I would want the core Hibernate ORM functionality. So I would choose the version 5.0.6 final, which is the latest that is available right now. So I can take this dependency, right click, copy, and I can make use of the dependency in here. Now I'm adding a dependency on Hibernate for this particular project. You'd see what would happen now. So I've not saved it yet, so you don't see it in the Maven dependencies, but as soon as I click save, you'd see that there's a building workspace going on here. So Eclipse is trying to build the workspace. So that means it's actually trying to download the Hibernate jar. So it downloads the Hibernate jar, and you'd see after some time that the Hibernate jar would come in here. So there you see the Hibernate core.jar has come in, and along with it, it has brought in a lot of other jars as well. We'll discuss about them a little later when we talk about transitive dependencies. But the most important thing right now is in the Maven dependencies of this particular project, we have the Hibernate core as well. That's the third important part of a Maven POM. The third important part of a Maven POM are the definitions of the dependency. There are a few tricky things about the POM.xml that we would look at in the further steps. One of the tricky things is something called scope. Scope of a project is something which we will look at a little later. The other thing which we will look at later is packaging. So a packaging defines how you would want to package the output of this particular POM. The default packaging is jar. So when this particular project is compiled and executed and installed, then it is packaged up as a jar. That's what the packaging would indicate. We would look at it in detail a little later. The other thing which we would be looking at is how you can make the version having a range instead of a specific version. Those are the three things which we would look at in a further steps. Until then, in this step, let's learn about transitive dependencies. What are transitive dependencies and how does Maven handle them? In the earlier example, we saw that when we added in the Hibernate core jar, along with it, there are a lot of jars that were added in here. So I'll try and remove this right now. So I'm removing the Hibernate jar. You'd see that everything in the Maven dependencies except for JUnit jar are disappearing. Let's add in the Hibernate jar right now. So I would add in the Hibernate jar. So you'd see that there are a lot of jars which are added in. So not just the Hibernate core. I'm adding org Hibernate core 5.0.6 final. That's what is highlighted on the screen right now. But along with it, there are a lot of dependencies which are coming in here. These dependencies are what are called transitive dependencies. These are basically the dependencies of the Hibernate framework. The thing is, we want Hibernate, and in turn, Hibernate needs other frameworks for it to work. Those are the dependencies of Hibernate framework. The dependencies of the Hibernate framework are defined in the Hibernate POM file. How do I get there? I can do a control. So if you press the command or the control and click on the dependency, you would bring up a pom.xml file. So what you are looking at right now is the pom.xml of Hibernate framework. You would see that there is a Hibernate core. The version in here, the packaging is jar. So Hibernate is a jar file, so the packaging for it is jar. That's also the default packaging. And if I go in further, you'd see that there are a lot of other dependencies defined in here. So if you look at the dependencies, there is a JBoss logging. There is a lot, that's what we would see in here as well, JBoss logging. And Hibernate JPA 2.1 API, Hibernate JPA 2.1 API, Java Assist, that's basically what we have in here. So all the other dependencies which are coming in here are because of the Hibernate. So those are the dependencies of Hibernate. These are what are called transitive dependencies. The transitive dependencies are nothing but the dependencies of the dependencies that we include in here. So if you want to see all the dependencies that come in, one of the ways is to go to Maven dependencies, and the other way is to go to the dependency hierarchy tab in Eclipse. So if you go to the dependency hierarchy tab, it shows in all the resolved dependencies. On the right hand side at the end are all the resolved dependencies. If you want to find out how we are getting the dependency, so you see that there's a DOM4j in here. I don't want to use DOM4j. I want to find out where the DOM4j is coming in. I just click on it. So I click on it, then it says DOM4j is coming because I have Hibernate core. And if you include on JBoss logging, it says JBoss logging is coming in because it's used in two things. One is Hibernate core and Hibernate common annotations, which is actually a dependency of Hibernate core. So these are how you can see the different, this is how you can see the transitive dependencies of a specific project. You can go to the dependency hierarchy tab in Eclipse. In this step, let's learn how to exclude a transitive dependency. Earlier, we saw that we included the Hibernate core in, but along with it, I got a lot of things for free. I mean, a lot of things in here. But let's say I don't want to use the JBoss logging framework. I want to use log4j, which I would want to add in later, but I wouldn't want to use the JBoss logging framework. So I want to exclude the JBoss logging framework from my Maven dependencies. I don't want that to be part of my Maven dependencies. How do I do that? The way you can do that is by using something called a exclusion. So what I'm doing is I'm copying in the dependency. I mean the dependency which I want to exclude, I'm copying it in. So I just click in here, I mean control and click in here, it would open the Hibernate POM. I located the JBoss logging, or you can actually go to dependency hierarchy and identify the org ID, I mean the group ID and the artifact ID of the JBoss logging jar, because that's what we would want to exclude. And then I can say I want Hibernate dependency, but I don't want a few dependencies of Hibernate. You can specify that by using the exclusions tab. So exclusions. So what do I want to exclude? Exclusion. You can specify in here the group ID and the artifact ID. So I'm copying in the thing which I used. So inside the exclusion, I'm specifying the group ID and the artifact ID. I don't need to specify the version in here. You can just specify the group ID and the artifact ID in the exclusion, and I'm formatting the, you'd see now that the JBoss logging is not in the Maven dependencies. Just for us to have a clear picture, I'll just remove this exclusion, Control S. You'd see that the JBoss logging is added in is because right now it's not excluded, but once I exclude it, you'd see that the JBoss logging has disappeared. So that's how you exclude dependencies from a project. A lot of times you would want to exclude dependencies because you don't want your final vars and the EARs to include a lot of unnecessary jars. Because if the EAR or the jar file is big, it might result in a few performance issues. I mean, not really important thing. I mean, when performance is, as far as the performance is concerned, it might have very limited impact. But if you want your whole EAR to be clean and as minimal size as possible, then you would want to exclude all the jars that you don't want to use. So this is how you add an exclusion for a specific In this step, let's learn about another important thing in dependency management, which is called the scope. Along with dependency, you can specify a scope. So what we'll learn is what is scope and why is scope used. Let's consider this particular thing, JUnit jar. The JUnit jar is only used in the test files because I use JUnit framework to run JUnit. There might be other frameworks like Spring Unit, Mockito, EasyMock, which also would be used only while running the tests. I don't want them to be used to run the source code. So when I'm doing the source code, when I'm compiling the source code, I don't want these jars to be used. I want these jars to be used only when compiling test classes. So how do I say that this JUnit has to be used only while compiling the test classes? The way you can do that is by using a scope variable. So I can say scope test. Once I say something in test scope, then it will not be available for the source code to make use of it. So it will only be available in the scope of test. So when I'm compiling test files, when I'm running the test files, this jar would be available. And when I run the compilation of the actual code, then this particular jar would not be available. If you look at the other kinds of scopes which are present, I'm doing a control space. There are other things which are present, which is compile. Compile is the default scope. Basically, whenever we do the compile, it's available. So it's available for source code, test code, and anything else as well. And if this jar is used in a var, then all the dependencies would be packaged along with the particular var. The other important scope is runtime. So the importance of the runtime is that the jar which is specified as runtime jar will not be available at compile time. So when you are compiling this particular piece of code, this particular jar will not be available. So let's say if I go to app.java and add in this import. So I'm just for fun, I'm adding in this static import in here. I've made the JUnit a runtime dependency, not a compile time dependency. So I've made it a runtime dependency. I'll do a right click, Maven, update project, just to make sure that the project is updated. And then I would do right click, run as mvn install. When I did an mvn clean and mvn install, I see that there is an error. It says fail to compile because it was not able to find the test class. org.junit does not exist because when I say something is available at runtime, the jar is packaged along with the var. So if this is a dependency, the JUnit dependency would be packaged along with the var file where this particular project is used. However, it will not be used when it's compiling the code. So when it's doing the Java compile for this particular thing, this will not be used. This kind of a runtime scope is very, very useful when we are using APIs and IMPLs. Usually when I'm building any application, I want to be dependent on the interfaces but not the implementation. So what we would do is we would create a separate API jar and the IMPL jar. The API jar would be available at compile time, so I can use the methods which are there in the API directly. But the IMPL jar would only be available at runtime, so that I'm not dependent on any of the implementation things. I'm only using the interfaces and I'm not using the implementations. Thereby, tomorrow I would want to switch to another implementation, I can easily switch to it. So that's the scope that we were discussing, which is scope of runtime. There is another scope called provided. When something is provided, what happens is this particular jar will not be included in the var which is created. It is assumed that this particular jar would be provided by the application server. Let's say WebSphere probably comes in with a set of default jars. I mean, it might come up with its own thing on Servlet API. So why do we really need to include that jar as part of our var? We don't need to. So if I say scope provided, then this particular jar will not be present inside the jar when it's built up. So these are the important scopes. So if to summarize, to summarize, the default scope is compile. So compile is default. It's available for everything. The next one is test. When I say something is test scope, it's only available for the test code. So it's only available for the code which is inside the source test Java folder. When I say something is runtime scope, then it's not available during the compile. So when I compile this code in here, this jar will not be available at all. When I'm running the whole thing, this jar would be available. But when I'm compiling the code, it will not be available. The last scope which we discussed was provided. Provided is used for jars which are provided by the application server. For example, something like a servlet API jar which is directly present in WebSphere, Tomcat, or any of the web servers that you take. So for those kind of jars, we use the scope provided. Scope is kind of a tricky topic to understand. If you have any questions about this, do leave them in here. And if you are not having a complete understanding of it, don't worry about it. We will come back to scope and discuss about it when we discuss about the var files. Now that we looked at the scope of a particular dependency, we would now focus a little bit more on the version. In here, until now, we specified exact versions: 4.4, 5.0.6 final. We specified the exact version. But sometimes it might be good to specify a range of versions to use. For example, let's say I am okay with using any version up to in a specific range. So let's say I want to use something which is greater than 4.1. If I specify something of this kind, 4.1 open bracket and close bracket, then it would get the latest version available which is greater than 4.1. So what we are saying in here is the minimum version I want to use is 4.1. You can also say 4.5. So 4.1 to 4.5. You would see in here now that once the building workspace is complete, the maximum version I'm specifying is 4.5. You can also say, this is 4.5 and below. If you don't want to use to 4.5, so you only want to use less than 4.5, you can use the other bracket. Now you would see that 4.4.jar. So in summary, it's very simple. You can specify a range of jars. If you use a square bracket, then it's including the particular thing. So if I put a square bracket 4.5, then it means 4.5 and everything less than 4.5. On the left hand side, this means 4.1 and everything greater than 4.1. You may or may not specify the maximum or the minimum. So now I'm not specifying the maximum, so it takes the latest jar which is available, which is 4.12. And the other option is not specifying the minimum, so basically saying that 4.5 is the maximum version I want to use. That's fine too. So JUnit 4.5 is now being used because JUnit 4.5 is available. The largest version of the JUnit available right now, as we looked at earlier, is 4.12. So if I say 4.45, let's say, then it would get the latest available version, which is 4.12. This is how you can specify a range of versions in your dependence. In the next two steps, we would understand what happens in the background of Maven. We specified in the pom.xml one dependency. We said, I'm dependent on Hibernate. I'm dependent on JUnit 4.12. But how is actually Maven going and getting this JUnit jar? How is it getting it? Where is it getting it from? And how does the whole thing work? That's basically what we would be discussing in this step and the next step. There are two useful commands which are very useful in understanding what happens in the background of Maven. The first of those commands we would look at in this particular step. So I'm going to execute a command, run as mvn build. The command which we're going to use right now is help. Help is one of the Maven plugins which is very useful. It has a lot of useful goals. The goal which we are going to use right now is effective pom. The command which we're going to execute is help:effective pom. If I execute this command, you'd see that a lot of content is printed out to the console. I don't want it to be printed to the console, but I would want to output it to a file. So I'll pass in our option -d output is equal to effective-pom.xml. So basically I'm typing in help:effective-pom -d output is equal to effective-pom.xml. This is how you pass parameters to a Maven plugin or to a Maven goal. So the way you do that is -d, the name of the parameter and the value. So what I'm trying to do is I'm trying to take the output and write it to this particular XML file. Let's run this. So it says effective-pom is written to a file in effective-pom.xml. Let's bring that up. I'll refresh this project so that it comes up. Unfortunately, it's not automatically refreshed. So effective-pom.xml. If I go to this XML and look at it, this effective-pom is actually a very, very important thing. Thing is, when we created the POM file, it has only about 31 lines of code. So the POM file which we used has 31 lines of code. But the effective-pom, if we look at it, I mean, there are a few comments, but it has about 259 lines of code. So what does it really contain? First things that it contains is the default structure. We did not specify anything in our Maven pom.xml where our source code should be. So the source code, source main Java. This is a Maven defined defaults. This is called convention over configuration. Any Maven project uses this similar structure. So source main Java is where by default the source code would be. I can override it if I want to, but in most of the projects which use Maven, the structure which is used is source main Java. So where do we say that the source code should be in source main Java? That actually is in the effective-pom. The way the Maven hierarchy of POMs works is just like in Java. In Java, object is the superclass of every class. Similar to that, in Maven, there is something called a super POM. A super POM is the parent POM for all the POMs. So when we define this particular POM, then along with it, this extends a super POM. And the effective-pom.xml is basically a combination of the super POM and our pom.xml. The super POM contains the settings, the default settings that Maven provides. For example, the source folder path. So if I search for source main in here, you'd see that there is a folder where there's a section called build where it's specified as source directory. I can create a build in here and override the source directory. If I don't want to use this folder as the source directory and I want to use source main source, that's fine. You can go ahead and override. But this is the default. The defaults are all defined in something called a super POM. The super POM defines the default source directory, default test directory, default output directory. That's basically the target folder where the output of the source files is stored. Default test output directory, it's test classes, target test classes. That's what we have been looking at until now. Resources, test resources. All the defaults are defined in this particular superpom.xml. The superpom.xml also defines a lot of plugins that Maven uses by default. For example, there is something called a compiler plugin which actually does the compilation. So if you look at it, we are using 2.5.1 version of the Maven compiler plugin, and the show-fire plugin in here is used to run the JUnit tests. So these are all the things that we get for free from the superpom. The superpom kinds of configures the defaults for any POM. And effective-pom, I mean the command which we executed earlier, which was right-click, run as mvn build. The command which we executed was help :effective-pom, and we said -d output is equal to the file where you would want to send the output to. So it's effective-pom.xml. So this is how you would be able to create an effective POM and send the output to XML. If you don't want to do this, you can actually leave this empty and just say help :effective POM. Actually, the entire thing would be printed to the console. So you'd see now that a lot of information is printed into the console. If I just scroll down in here, there would be a big XML which is printed in the console. You can do this as well to see the XML, but I did this so that I can have the entire effective POM in a XML file. Along with the default directories and the default plugins, there's an important part which is present in this effective pom.xml, which is the repositories section. If you look at this, this is the central Maven repository where all the jars are stored. So how does our Maven project know where to get the jars from? Once we defined org.hibernate, hibernate core 5.0.6 final, where does it go to get the jars? The place it goes to get the jars is the central Maven repository. That's what we have configured in here. We can override this. We can override this and create a few more repositories and use them as well. But by default, we would be using the central Maven repository, which is at that particular URL. If you go to this repository, you would see a lot of things in here. So the specific thing that we are interested in is, let's say we'll take the JUnit. So JUnit 4.12. So I'll search for JUnit in here. So JUnit, you'd see a lot of things. So JUnit, you'd see a lot of versions of JUnit in here, and the version which we are using is 4.12. So the jar file is present in here. So what Maven does is it takes this jar file and stores it into a local repository. We will look at local repository in the next step. In this step, let's assume that this jar which is there, it's copied and downloaded to our local repository, and what happens in here is in the build path of the project. So when we have the properties, and you can look at the Java build path, you would see what is added in are the Maven dependencies. So you'd see that the Maven dependency is actually picked up from a local Maven repository. If you see user rangarao.karnam.m2/repository/ a lot of things. So this is actually coming from a local folder which is called the local repository. So the way it works is, when I specify a jar version, Maven goes to this repository, gets the jar, puts it to a local folder, and the jar from the local folder is included in the build path of our project, and that's how the entire magic of Maven is happening. If this particular section is a little confusing, don't worry. Try and go through the whole video again, because this is a very important thing to understand. I think understanding how a specific tool works is as important as making use of that particular tool. So if you understand how the whole thing works, then if there's a problem, you can debug it very easily. And I think this particular step is very important in getting a deeper understanding about Maven. Try and repeat this section again and try and do everything, and you can also spend some time looking at the effective POM and seeing all the different things that are present in here. In summary, the effective POM is a union of our POM and something called a super POM. Super POM is kind of the parent of all the POMs, just like object class is the super class of all the classes in Java. The super POM defines the defaults. It defines the default directories, it defines the default repositories where you can find the jars. It also defines the default plugins which Maven makes use of. The most important thing about the super POM is everything in the super POM can be overridden in our project POM. So if I don't want to use a specific source directory or a specific test directory, I can override it in my POM. But super POM kind of specifies the defaults, and it is the main crux of the Maven's philosophy of convention over configuration. In the earlier step, we looked at help effective POM. There is one more important command which is in the help plugin, which is help effective settings. I will also output this to a file, so I would do -d output is equal to effective -settings.xml. I could have named it anything. I just want to output to a file, so I'm doing that right now. I've done that command, and let's refresh so that I would get the effective settings pom.xml in here. Oops, it's still running, so it's not yet created the file. Now it's finished. So let's see if the effective settings file is created. Refresh. Here we go. Effective settings.xml. So what does the effective settings contain? The effective settings the most important configuration which is there in the effective settings is the local directory. So if you look at this, users rangarao.karnam.m2 and repository is my local repository. What we discussed in the earlier step is that whenever a jar is downloaded, I mean, if let's say I want to download a particular jar, so I want to use Hibernate 5.0.6, what happens is the Maven goes to the configured repository. We saw the URL to the central repository in the earlier step. So it goes to the central repository, it gets that jar and puts it in this particular local directory. So that's the reason why you would see that if I do a right click, properties, and see the libraries in the Maven dependencies, it would show the directory in here. I could have actually directly went in directly in here. So if you look at the path which is in here, the Hibernate Core 5.6 final is in users rangarao.karnam.m2 repository, and that's coming from the configuration of the settings.xml. So the local repository is configured in here. If I look at it in here, it says the complete directory. So it's users rangarao.karnam.m2 repository, and that's where all the jar files are. Even if I create a new project which uses the same version, let's say I'm creating a second Maven project which uses Hibernate Core 5.0.6 final, it would still be picked up from the same local repository. So the local repository kind of serves as a cache. So before, if I want to download anything from the remote repository, I would first check in against the local repository. If it's not there in the local repository, Maven would go and fetch it from the remote repository. So that's how it works. Basically, the local repository kind of serves as a cache to the remote repository. Let's look at what's there in my local repository. I'll go to my folder users rangarao.karnam.m2, and you'd see a whole lot of folders in here. You can see that there are hundreds of folders in here, inside which there are a lot of jar files which are downloaded in here. So this kinds of acts as a temporary cache for everything that we are working on in here. So there are a lot of jars in here, different versions of it, which are present in my local repository. There is a settings file in the Maven where you can override these defaults as well. So in the settings.xml, you can override the local repository. So if you don't want to use this rangarao.karnam.m2.repository as your local repository, or whatever is configured by default, you can change it. You can say I want to use .m2 as the repository and not repository. So that can be changed. You have to create a settings.xml and put it in the Maven conf folder. So the last couple of steps I think are really important in understanding how Maven works. Effective POM and effective settings are quite important. I would recommend you to spend some time looking at the effective pom.xml and the effective settings.xml, which are generated in here, and try and understand the different chunks in there. If you have any questions, do post it in the comments. Until the next step, bye bye. In this step, let's focus on one of the fundamental concepts in Maven, which is plugins. Let's take a practical example. In here, we see that the JRE system library which is being used is 1.5. Aha, very old. So that's the default I got from Maven. So now I would want to use the JDK 1.8 to compile this. I don't want to use JDK 1.5. I don't want to use Java 5. I want to use JDK 1.8 or Java 8, whichever way you would want to call it. So I would want to use Java 8 for running this example. How do I change that? What I would do is I would go to the effective POM that we generated earlier. So I'd go to the effective POM and search for something called compiler. The source version to use is one of the properties that you can pass to the Maven compiler plugin. So let's now take this. I'm copying the entire plugin. So I'm copying entire plugin for that particular thing. So I started from line 148 and copied until the line 167. It might be a little different in your machine. But basically I'm copying the entire plugin tag which contains the compiler, and I would put it in the pom.xml. I would want to make use of the Maven compiler plugin, but the Maven compiler plugin is using JDK 1.5. I don't want to do that. I would want to override it. Where do I override? The place where we would be able to override is in, I'll go to the build. So in the build section, oops, I missed a D build. In the build, you'd have something called, in the build, there is something called plugins. So I would go to plugins, and in the plugin, I would paste whatever I have. I don't want to change anything about the version or the executions. So I would remove them in, but what I would want to change is the configuration of this particular plugin. So what I'll do is I'll type in configuration/configuration, and I can pass in a source. I would want to use 1.8 as the source and also target. So I would want to use JDK 1.8 to compile, and the target version is also 1.8. That's how I'm specifying in this here. And now if I go ahead and do a right click, Maven update project, this is how I can refresh the Maven settings. You would see that we would start using Java SE 1.8. So basically what we are doing in here is we changed the configuration. So we changed the Maven compiler plugin to use JDK 1.8 to compile our code. This kind of things are where the plugins come in. The plugins add in a lot of value to what you can do with Maven. There are different kinds of Maven plugins. We earlier looked at Maven compiler plugin, which is used to compile, Maven Surefire plugin, which is used to run unit tests. We looked at Maven jar plugin, which is used to build the jar up. We looked at Maven install plugin, which is used to copy the jar from which is created, to the local repository. Other than this, there are a lot of other plugins which are not used by default in Maven. For example, there is something called a Tomcat plugin, which can be used to deploy a application, a var file, to Tomcat. We can also override the version of the Maven compiler plugin that we want to use. Let's say I want to use 3.2 version. I can change that in here. So similar to dependencies, you can have a group ID, artifact ID, and version for the plugin, and also the configuration in here. Another important thing to note in the plugins is the phase. So if you look at this, it says compile phase. So this plugin, the Maven compiler plugin, is run during which phase? It's run during the compile phase. So similarly, if I look at the other plugins, you'd see that Surefire plugin. The Surefire plugin runs the test. Which phase? Test phase. So these are all the build lifecycle phases. We looked at 8 or 9 different build lifecycle phases earlier. So this phase defines when this plugin is made use of. So what happens is when I define a phase, Maven during that phase would invoke this plugin with this particular goal. So Maven would call this Maven Surefire plugin in the test phase with the goal test. So similar to that, you'd see other plugins also have phase and goals defined. So if you look at the default ones, they have similar phases and goals, but they don't really necessarily be the same. So the important thing is the phase. Install. In the install phase, the Maven install plugin would be called. So similarly, you would have the deploy and also the site plugins, which have the phases as site and deploy respectively. So those are the important things that you would need to know about plugins. We will discuss a little bit more about plugins when we add in our Tomcat plugin in a future step. Until then, hold on to this. Until now, we have executed a lot of Maven commands from inside Eclipse. We did a right click, run as, and did a lot of things. I really hate this way of running Maven commands. I really like running Maven commands from the command prompt, and that's what we would learn during this particular video. This particular project is in a particular folder, right? I mean, if you look at the resource in here, it's in Programming Excellence, Workspaces, Maven Step by Step, First Maven project. So what I'll do is I'll copy this folder location and open up terminal. If you're using Windows, then you need to launch up your command prompt, and you need to do a cd to the folder where our project was in. So I'm doing that in here. So I'm seeding to that particular folder where I copied it by doing a right click properties and going to the resources section. So I'm in that particular folder right now. How do I know what version of Maven I'm using? You can use the command mvn-version. Is that right? Yep. So let's look at this. It prints the version which is being used, which is Apache Maven 3.3.3. It also prints the Maven home folder. So my Maven home is in this particular folder. It prints the Java version which is being used, which is 1.8, and also the Java home directory. So that's all very good. So if you don't see this being printed, then you don't have Maven properly installed from your command prompt. The Eclipse which is used from your Eclipse is little different from the Eclipse which is used from your command prompt. If you have any problems, I would recommend you go to the installation guide which we have in the folder in 28 minutes. In addition to installing Eclipse and Java, this would also help you to install Maven outside your Eclipse. So here we would want to use the Eclipse which is outside the Maven. That's what we are running from the command prompt. And if I want to run mvn clean install from here, so mvn clean install, earlier we were doing a right click mvn in build and typing in the goal. You can now see how easy it is to run things from the command prompt. You'd see all the things being executed. I mean the tests running, the compilation, test compilation, and all the other sequence of build lifecycle steps are done from here. So if I want to type in mvn effective, the earlier commands help colon effective hyphen pom, you can type that in and the effective pom would be printed into the command prompt. So whatever we have done, all the commands that we have executed until now, you can also run them from outside Eclipse. So this is how you do that. You'd use mvn space the goal you would want to execute. So mvn is the executable name and install is the goal. So I'm typing mvn space the goal which I want to execute, and then the complete thing runs. From here on in this particular course, we would be using command line to execute everything. Until now, we have looked at Maven projects which are very simple. I mean, most of the Maven projects that we looked at had just one pom.xml. So this pom.xml was what we used to specify the dependencies and everything. But real world projects are more complex than this. Real world projects contains multiple layers. You have a business layer, a web layer, a data layer, and probably a IMPL and APIs for each of these layers. So in real world, we use something called multi-module Maven projects. In this particular step, we will get a brief idea about the multi-module Maven projects. How do you create a multi-layered project with Maven, and how do you specify dependencies in there? That's what we would be focusing on in this particular step. How do you create a multi-module Maven project? It's very simple. You'd start with the same way as your Maven project earlier. I'm saying file new Maven project. I'll not use archetypes, so I'll check this up and say next. The only thing that is very different is packaging should be POM. Earlier the packaging which we're using was a jar. So we wanted to create a jar file, so we were using packaging jar. But now to create a multi-module project, I would need to have POM as the parent. So let's look at it a little in detail a little later, but for now you can say packaging as POM, and I would say the group ID is com.in28minutes. I mean, you can basically give anything in here. I'm giving com.in28 minutes, and artifact ID I would want to use is multi-module Maven project. So that's basically all that we need, and I click finish. You can see that a small project is created with some source file in there, actually nothing in there, and there's a pom.xml which is created. The pom.xml contains the group ID which we specified, the artifact ID which we specified, and the packaging is POM. So that's the first step to creating a multi-module Maven project. Now we have the parent POM. This POM is called the parent POM. I mean it acts as the parent to all the POMs which would be underneath this. What we want to do is we would want to create two modules in here. One module I would want to call this as business, and the other module I would want to call it as data. So under this particular POM, I would want to create two different projects. How do I do that? So I'll start with file, new, other, and now instead of Maven project, I would choose Maven module. I want to create a module by the name business. So how do I do that? I would say next, and I would again say create a simple project, and I would specify the module name in here. So it's the module name is business. That's what I would want to use it. For now, I'll keep it very simple. I'll not separate business API and MPLs. Let's have one module which is called business, and I'll click finish. You can see that there's a new project created, business. If you look at the pom.xml for business, it has a parent reference to the earlier POM that we have created. So if you look at this particular POM that we had in the multi-module Maven project, the group ID, artifact ID, and version of this are used in the business POM. So group ID, artifact ID, and version, and this is the parent. So now the multi-module Maven project POM is treated as the POM for the business POM. And the other important thing is there's a module section added in. So the modules section now contains a module business, and you'd see that the artifact ID business is used in here as well. So if I actually refresh this particular thing, you'd see that there's a folder called business which is created in here. So in the multi-module Maven project, we specify the module as business. So now we have created a module business, and this module contains another POM which is a jar. So the packaging for the parent POM is POM, and the packaging for the business POM is jar. I mean, there's no packaging in here. That means by default it is a jar. As we decided earlier, we'll use command prompt from now on. So I'll cd to that particular folder. Now I would do a mvn clean. You'd see that there are two projects which are running right now. The first one is the multi-module Maven project, and the other one is the business project. What we would do now is we would create the module on our own. So now what we would do is we would want to create a data module. So what I'll do is I'll now need to add in a module data. So I'll say module data. So I did that. In addition to that, I need to create a new folder. What is the name of the folder that I would need to create? It should be the same as the name of the module. So the name of the module was data. So I would go ahead and name this as data. So now I have data. I need a pom.xml. So I'll copy the pom.xml that we used for business. We need to make a few modifications in there. We would want to use the artifact ID as not business, but we want to use data as the artifact ID. I would leave the parent POM as it is because I would want to use the earlier one as the parent. Now let's do a build and let's see if it's working fine. Okay, there you go. So we have created now a multi-module Maven project with two modules, a business layer and a data layer, and we are able to get it compiled successfully. In the next step, let's see how to play around with this a little more. In this step, let's play around with the multi-module projects a little bit more and try to understand the best practices which are related to maintaining multi-module project POMs. What we have until now is we have a multi-module project parent POM. This is the parent POM where we have the version specified and the packaging is POM. And we have two Java modules which are business, and this does not have packaging in here, which means the default is jar. And we also have a data POM which is also in here, and it also does not have packaging, which means it's a jar. So now I would want to add a few dependencies to the data layer. What would we typically use in a data layer? So let's add a few dependencies in here. So I would start with adding a dependency for Spring Framework because I would want to use Spring in the dependency layer, and I would specify a version in here as well. Let's just say 4.2.3, which is kind of the latest version which is available right now. And also let's say at the data layer we are using Hibernate. So I would pick up Hibernate as well from the earlier project that we had. So I can go here and pick up Hibernate. So let's add a dependency on Hibernate quickly. Now I'll put in the group IDs for Hibernate as well. and format the whole thing up. So there you go. Now the data layer is now dependent on Spring and Hibernate. That's very good. And what do we want to use in the business layer? We want to use, let's say, Spring. I don't want to use any other frameworks in here for now. Let's just say dependencies, and I would add in the dependency Spring. So that's very good. So now what do we have? We have a simple multi-layer project in which the business layer is dependent on Spring and the data layer is dependent on Spring and Hibernate. There's a small mistake with the version of Spring. Spring ends the versions with dot release, so I had to actually use 4.1.0 dot release. So I would also update the data POM to use not 4.2.3 but actually 4.2.3.release. So let's build this project from command prompt mvn clean install. You'd see that the business and data projects are being built, and also you'd see that there would not be any compilation errors as well. That's really good. So now we are able to add a couple of jars, Spring jar, to the business module, and the data module has its own dependencies. This is how the different projects, different modules in a project can have different dependencies. So now also one more thing that you would notice is that the versions are maintained in the child POMs as well. So that's a very bad practice, because now if I have to change the Spring version from 4.2.3 to 4.2.5, let's say, I have to change it multiple places in the POMs. A better way of doing that would have been to use the dependency management tag inside the parent POM. So I can use the dependency management tag. So I'm going to the parent POM and saying dependency management, and I can add in all the dependencies that I would want to manage in here. So once I specify dependency version in the parent POM, I don't need to really specify any versions in the child POM. So now once I added in the dependency management in here, I have to surround this with dependencies tag. That's why you have the comp error. So now once I put it in here, I don't need to specify the version in here. So you are already getting a warning in the child POM that it's overriding. So why do we need to override? I can directly remove this. So the same is the case with data. So now I don't need to specify the versions in each of the individual POMs. So now this is how you add individual dependencies to modules, and you have the parent POM manage the versions of all the dependencies. The other thing is also the fact that the data module, the business module wants to make use of the data module. How do I do that? The way you can do that is by adding a dependency on the data module. What I would do is in the business, sorry, I'm in the data POM, so this is not the right place actually. So I have to go to the business POM and I have to add a dependency on the data layer. So from the business layer in an application, I would want to make use of the data layer. So I would need to take the data as the dependency. So the artifact ID is data, and we actually use the same group ID as here. So I would actually put in the group ID as org 28 minutes. Now we have a dependency on the data module, but we have to also specify the version. The version of the data is same as the version of the business module. So what I would do is I would use a built-in variable which is there already in Maven. The way I would use a built-in variable is by using a dollar open brace and close brace, and inside that type in project.version. So now let's go outside and try and build this. So this is compiling without a problem. We can also have the management of the data being done from outside, from the parent POM. So we can directly put the dependency in the dependency management tag, this dependency, and I can in the business POM, I don't need to specify the project.version anymore. So now you have a project with two modules, business and data. The business module has a dependency on the data module, and also the business module has its own dependencies, and data module has its own dependencies as well. This is how you can create a very simple multi-module Maven project. Multi-module Maven projects is kind of a tricky topic to understand. So try and play around with this particular example. The example is on the GitHub repository, so you can take the example from there and try and play around with example to understand this furthermore. In this step, let's learn how to import a Maven project from Git. So I have a Git repository where there's a Maven project, and I would want to import that and run it in my Eclipse. So how do I do that? That's basically what we would be doing in this particular step. So the first thing is you need to do a file import, type in git, so projects from Git, and I would want to now first select the location of the Git repository. So what I would want to do is I would want to take the repository, which we already have. So we have a repository called Maven in 28 minutes where there is a particular project that we would want to use. So what I'll do is I'll download this particular thing. So this is what I would use as the repository. So github.com/in28minutes/maven in 28 minutes. I'll use this as the URL. So I'll say clone URI next, and I'll give the URI as this, and I would say it would not ask for any user ID password. It's because it's a public repository. You'd be able to read it from there. The branch it's saying is master. Yeah, that's fine. So go ahead and now say next. I would want to import this as a general project. Not specific thing. So I would just go ahead and say import it as a general project, and I would give it a name. So I'll give the project a name as Maven in 28 minutes, or you can call it Maven step by step. The most important thing is the directory. So just copy the directory as well. The directory is users and Rangarav Karnam git Maven in 28 minutes. So that's the important thing. So if you are able to copy it, you can copy it. Otherwise, we'll type it in. So click finish. So now you would see that the Maven in 28 minutes project is coming in here. So this is how you would import a project from Git. We are actually doing it in two different steps. One is we are importing a normal project from Git, and then we are making it a Maven project. So now we have downloaded the code from Git to my local. So all the code that we would want is in my local. So what I'll do is I'll do a right click, properties, and I'll copy the name of this particular folder. So it's in this particular folder. So I'll do a right click, copy. Now I can now import the Maven projects. How do I import a Maven project? File. What I'll do first is I'll delete this because I don't want to use it as a normal project. I would want to really create a Maven project for it. So I deleted the folder which we imported from the workspace. The files are deleted only from the workspace. Whatever we have imported from Git still remain in that particular folder. So I'll say file import Maven, existing Maven projects, click next, and the root directory is, I would want to say Maven in 28 minutes. I would want to, in this particular section, we would want to discuss the multi-module complex project that we have created. So I'll import the multi-module Maven project, select the multi-module Maven project, and you would see that a number of modules are present in here. You can go ahead and click. You would see that it would take some time for the whole thing to build. I would cd to this folder, right click, paste. This multi-module Maven project is a very complex example of a multi-module project. This has a data layer with API IMPL, a business layer with an API IMPL, and it also has all the code that is typically present in a business layer and a data layer. So if we run this particular thing, so if I do a mvn clean install in here, it actually does a lot of things. It would do the compile of the code, then it would actually run the test, and you'd see a lot of things happening in here. Now what we have done in here is actually we have imported a multi-module Maven project in here. What I would recommend you to do is to look at the structure of this particular thing. So you'd see that POM, inside the POM there are the packaging is POM, and there are three modules present. So the three modules which are present in here, if you look at it, are model, data, and business, and we have three folders in here. These are the different modules, and if you look at each one of these, let's say business, the POM has again two modules. The two modules are API and IMPL. So this business POM has two more modules, API and IMPL, and the API and POM are the individual jars. So the API is a jar and the IMPL is a jar on its own. So if you look at it, this POM has a packaging jar, and also if you look at it, this has a few dependencies which are defined in here as well. The business layer, as we know, would be dependent on the data layer. So it has a dependency on the data API as well as on the model. So this business layer is dependent on data and the model layer. The model acts as the domain object for this particular project. I would really recommend you to go through these projects and look into them and see if you have any questions. We have a lot of examples for you in the Git repository Maven in 28 minutes. In 28 minutes, Maven in 28 minutes. You can do a Google for it, it's easy to find. And in here, we have a number of Maven projects. We would recommend you at this stage to take the basic Maven example, the intermediate Maven example, the multi-module Maven project, these three things, and look at them in detail. So just go through the projects and see if you have questions related to any of those. During the last hour and a half, we have actually discussed a lot of things which are covered as part of these projects. In this particular step, we would learn how to run a web application with Maven, and that's what we would focus on during this particular step. What we want to do is we would want to download the code from GitHub. We have a sample web application in the folder for web application with Maven. So we would want to actually take this code from GitHub and we would want to run this project with Maven. So how do we do that? One of the options that you have is to download the zip and copy to a local folder and run it from there. The other option is actually to use Eclipse to import this GitHub repository to your local. What we can do is we can copy the Git project to your local, or the Git repository to your local, as a normal project. And then we will actually remove this project from the workspace and from the local disk. So we have this on the local disk. So from the local disk, we will import it as a Maven project. So that's what we are going to do right now in this particular step. So what I'll do is I'll do file import. I'll just say git in here. So projects from git, go and do next. I would say clone URI. So I would want to actually take whatever is in here and copy that. So I'll say clone URI, and the URI is this. So now I would want to actually copy it in here. So I would go ahead and copy in here. You don't need a user ID and password because this is a public repository. And I would want to take the master branch, and you can now copy it to a different folder. So let's say Maven in 28 minutes 2. So that's where I'm going to store this particular thing. So what I'll do is I'll copy this. So I'll copy this folder so that I know where I'm copying to from the Git. So what happens now is whatever code is present in this repository. So there are 5 projects in this particular repository. All of them get copied to my local folder. So let's do a next, and you are seeing that all the projects are being copied and also a working directory is being created. So I'll say next again, and I'll name the project as Maven in 28 minutes 2. That's fine. Now you'd see that there's a project which is created in here which is called Maven in 28 minutes 2, and it has all the code that we saw in the Git repository. So it has 4 different projects, and also it has a presentation, which we are using in this particular course. The project which we would want to run as a web application is for web application with Maven. So what I'll do is open up the pom.xml in there. That consists of the configuration to be able to run a web application as part of Tomcat using a Maven plugin. So what we have defined in here, if you look at it, is a plugin. It's a Tomcat 7 Maven plugin. We are using Tomcat 7, so we are using the Tomcat 7 Maven plugin. Earlier versions of Tomcat are also available as plugins, but they would be using Tomcat-Maven plugin. So we are using Tomcat 7 Maven plugin, and what we are configuring in here is the var file which would be used. So the var file is also, the name of the var file is created by the var plugin. So if you look at this particular POM has multiple modules. So one of the modules which is present in here is the web servlet JSP module, which is packaged as a var. And this is the var we would want to run as part of the Tomcat. So what we are doing is we are configuring this particular Tomcat plugin for the var. So we are saying run this var as part of this Tomcat 7 plugin. So how can you run this web application from Maven? That's what we are going to look at right now. So the way you can do that is actually do a right click, properties. I'm going to find the path for this particular Maven project. So we are copying the pom.xml path. So we are copying the pom.xml path of the web application with Maven. So I'm doing a cd, right click and paste. So the first thing which we need to do is to build the project. So we would want to build the entire project. So how do we do that? Mvn clean install. So that would build the entire web application. So while it's going on in parallel, we would take a quick look at the structure of this particular project. So if you look at this particular project, you would see that this has three different modules: the core, web common and web servlet JSP. The core contains all the business logic. It contains the services and also the Hibernate logic to be able to run this particular application. This application uses a HSQL in-memory database. As far as this Maven course goes, that's not really important. But if you are interested in looking at how it works, please do take a look at how the entire application works. But what we are interested in here is how this project can be run using Maven, and let's see what happens right now. So we have done a mvn clean install and that completed successfully. So what we would need to do is we would need to cd into the module which contains the var. So this is the module which contains the var. So I would do a cd into that particular thing, cd in 28 minutes web servlet JSP, and now I can run that particular thing using mvn tomcat 7 colon run. So what we are doing is we are using the Tomcat 7 plugin as we saw earlier, and we are passing in a goal of run. So mvn tomcat 7 run, you'd see that this particular thing loads up it builds the entire project and it deploys it to Tomcat. Within a couple of minutes, you'd see that the Tomcat server is started up. So the Tomcat server is now started up. Now everything is loaded as well. So let's go ahead and run this application. How do I do that? Localhost 8080. Aha, that's great. So the user ID and password are inside one of the files in here called data.sql. So I can open that SQL file up. So the user ID is user@in28minutes.com and the password is password. So now I can log in and maintain to-dos. This is a simple servlet JSP application, but the focus was not on how the application was working, but on how you can use Maven to launch up a Tomcat application. The other thing which would be important from a development perspective is the fact that we have context reloadable set to true. What this means is that if I make a change to a servlet, so if I go to one of the servlets in the application and make a change, then it's automatically reloaded. I don't need to restart the server for every small change. So in this step, we launched up a sample web application in Tomcat using Maven. In this step, we will learn a lot of new Maven commands along with revising some of the commands which we have already learned. We would use our first Maven project that we have created as an example. So what I'll do is I'll do cd to that particular folder. So I'll do a cd to the first Maven project folder so that we would start using that as an example, and I'll do a clear so that we are starting off fresh. Okay, so one of the most important commands which we have learned is mvn clean install. So mvn clean install, as we know, runs all the important steps in a Maven build lifecycle. So it does the compile, test compile, run the tests, and also it would deploy, deploy the built out jar to a local repository. The next thing is mvn clean install. Sometimes you'd want to do skip tests. So if you don't want to run this test, then you can do mvn clean install -d skip tests. This is not really recommended. I would not really recommend you to skip the test all the time. But certain times, if let's say the tests take too much time to run, so there's a project where let's say the test takes half an hour to run. I mean, even in those kind of situations, I would not recommend you to skip the test, but I would want to show that there's an option to skip the test. So if you do -d skip test, then the test would not run. You would see that everything goes on as usual, but the test will not run. So the option is -d skip test. The other important option which usually is used for debugging is -x. When I do a mvn-x, actually it should have been capital X, that's why Maven was complaining, the Maven runs in debug mode. So in the debug mode, you'd see that there is a lot more log printed and a lot more information which is printed out. Whenever I have a problem with Maven in building some project and I'm not able to figure out what's happening, the first thing I would do is add mvn-X, and then you would have more information to go based on. Also, another important thing about mvn-X clean install is if you want to see how Maven is working, it's a very good thing. So what you can do is you can do mvn-X clean install and send it to a text file. So send it to a sample.txt, press enter, and all the thing that we would need would be written out to the sample.txt. And then you can take the sample.txt and look at it to understand what's happening behind the screen in Maven step by step. So it's a very useful thing to do, mvn-x clean install, sending it to a text file and trying to look at what's happening in there. We already looked at a couple of useful commands. A couple of useful commands from the help plugin. mvn help effective pom was the first one which we looked at, which printed the effective pom. It printed the pom with the super pom. So if a pom had a parent pom, then pom, parent pom, and its super pom and stuff like that. And we also looked at the option of sending it to an output file. So if I want to send the effective pom to an output file, I can say mvn help effective pom -d output is equal to file name.xml. This can be used to send the effective pom output to a file. Then I can open up the file and look at what's inside the effective pom. The other thing which we looked at also is effective settings. So the effective settings showed us what was the local repository which was used. So the help effective settings is also one more useful command. The next set of commands are useful in identifying problems with dependencies. So let's say you don't know how something is coming in, how a dependency is coming in. So in Eclipse, we were using the dependency tree. So the same thing is available as a command in Maven as well. So dependency :tree. So the dependency plugin has a goal called tree. So now I'm running mvn dependency :tree. You'd see that the entire dependency tree for this particular project is printed. So it shows we have Hibernate core from which we are we are getting these transitive dependencies as well. We are getting XML APIs because it's a dependency of DOM4j. So it kind of shows the entire dependency tree of that particular project. For certain projects, this can be really big, so you can probably transfer it to a text file and look at it in detail. But this was a small project, so the entire thing was printed in here and it's very easy to read in here. So this is how you look at the dependency tree. Sometimes you would want to look at the source code for the jar. So let's say I'm using Hibernate, but I want to look at the source for a particular Hibernate class. How do I do that? I can say mvn dependency sources, and then the dependency sources are also downloaded. So the source code for Hibernate is also downloaded. You can see that it's downloading the Hibernate final sources.jar, and it would be made available if I import this project in Eclipse. So that's another useful thing. So if I want to look at the source of Hibernate or Spring, then I can do mvn dependency :sources, and all the sources for all the dependencies are downloaded in. And if you have forgotten something and you need help, you always have the command mvn-help. If you type mvn-help, Maven shows you all the commands which are available, all the options which are available in Maven. There are a huge set of options which are available in Maven, so you can look at them as well in here. So there you go. Those were some of the important commands in Maven which might be really useful for you. In this step, Let's learn how to use Maven archetype plugin to generate sample projects for various frameworks. The command to use the archetype plugin in Maven is very simple. It's mvn archetype :generate. So we are using the generate goal of the archetype plugin and just press enter. You'd see that now Maven would come up with a huge list of project options. So it would come up with about 1000 plus Maven project options which you can create sample projects of. It would take a while because it's about 1000 projects, so usually it takes about a minute and a half before this would come up. There you go. So there is a set of projects which came up, and in here Maven is now asking me to enter a number for the project of which I would want to create a sample of. Maven is already suggesting a default of 705. I would go ahead and use the same default 705. If I don't enter anything, then it would take the default which is already suggested, which is 705. So I'll just press 705 and it's asking what is the archetype version you would want to make use of. I'll use the latest version, which is 1.1, so I'll type in 6 and I would want to give a group ID, so com in 28 minutes, and artifact ID I would give first Maven archetype. The version I would leave it at 1.0 snapshot. Package I would leave it as com.in 28 minutes, and it's asking for a confirmation finally, and I'll say yes, and there you go. So the sample project is now created using the Maven archetype, and if I do a ls on this particular project, then you would see that the first Maven archetype project is in here. So if I do a cd into that, cd first Maven archetype, and see the contents on it, there's a pom.xml and a source folder as well. So now I can import this project into Eclipse and see what are the contents which are present in there. How do I import a Maven project into Eclipse? It's very simple. File, import, type in Maven and existing Maven projects and say next, and say the root directory, we have already copied it, and say finish. So now the entire project which we have created is in here as a Maven project. So you'd see that there's a sample app.java in here which has a system.out.println, and you'd see that there's a test folder also created with a sample test which is app-test.java, and it's using a very old version of JUnit that I can see because it's using a test case, it extends test case, and you'd see that there's a pom.xml also created, and the pom.xml contains all the things that we have defined earlier, group ID, artifact ID, and you'd see that there's a dependency on JUnit 3.8 with the scope as test. So this is kind of a sample project which we created directly using Maven archetypes. So similar to this project, you can create n number of projects using Maven archetypes. There are archetypes for Spring MVC, Struts, Hibernate, and a lot of other projects. So you can go ahead and explore what are the archetypes which are present and try to figure out which archetypes would be really useful for you. So there you go. That's what archetypes are used to do, generate sample projects. Good. Congratulations. You have learned a lot of things about Maven in this particular course. We started with what is Maven and how it really helps a developer. We saw the different things Maven helps us do, and we also practically executed a lot of things. We got a lot of depth into our Maven fundamentals. We understood what is a build life cycle, what are the different parts in a project object model, and what are the important things related to dependency management. We also looked at super, and then we moved into multi-module Maven projects. At the end, we looked at a few important commands which would be useful while debugging Maven projects, as well as looked at Maven archetypes, which would help us to generate a lot of projects. That's a lot of ground that we have covered in the last hour and a half. Thanks for your patience for seeing through this particular course, and good luck with whatever you want to do. All the best. Bye-bye.